Pre-AP Pre-Calculus. This is homework 10.5, solving trig equations. Direction: solve the equations below, find exact solutions on the interval from 0 to 2 pi, round your answers to the nearest thousandth of a radian if necessary. So we're going to be doing rounding if we have to use our calculator. If we end up with an angle that is special, multiple of 30 or multiple of 45, then we're not going to use a calculator, not going to round. So in order to solve this equation, when I get theta by itself, I'm going to divide both sides of the equation by 4. Then I'm going to square root both sides. It's going to give me sine of theta is plus or minus. Square root of 3, don't know. Square root of 4 is 2. This gives me two scenarios. Either sine of theta is square root of 3 over 2, or sine of theta is negative square root of 3 over 2. Solving for theta, I'm going to apply sine inverse to both sides of the equation and get theta is sine inverse of square root of 3 over 2, or theta is sine inverse of negative square root of 3 over 2. In both cases, I'm going to have the same reference triangle. This first equation, sine inverse of square root of 3 over 2, that means the y has to be positive, that's quadrants 1 or 2. Sine inverse of negative 3 square root of 3 over 2, the sign has to be negative, that's in quadrant 3 or 4. So in order for this y value to be square root of 3 over 2, that's a 30, 60, 90 triangle. Opposite of y in this case is going to be pi over 3. So my answers for this, I'm going to get pi over 3. And then from here to here, I'm pi over 3 short of getting to pi. That's going to be 2 pi over 3. And over here, for these angles that are down here, let me redraw a picture for that. This one here is going to be pi over 3 more than pi, which is 4 pi over 3. And then over here, it's going to be pi over 3 short of 2 pi, which is going to be 5 pi over 3. So my four answers are those fellas right there. Number 2, I want to get the 2 by itself, and I want also this to be one trig function. I'm going to change tangent to sine over cosine. If I divide both sides of the equation, I guess I don't want to do that. Tell you what I'm going to do. Let's get everything on the same side of the equation. Let's do that. Let's multiply both sides by cosine. That's going to give me, so I misspoke. I don't necessarily want to get everything in terms of one trig function. What I want to do is I want to get all the terms on the same side and then factor it and see what good comes of that. And then if I subtract sine of theta from both sides, I get 0 equals 2 sine of theta cosine of theta minus sine of theta. If we GCF this, we're going to get sine of theta times 2 cosine of theta minus 1. Once it's factored, we're going to set each factor equal to 0. So we got sine of theta equal to 0. And we got 2 cosine of theta minus 1 is equal to 0. So theta is sine inverse of 0. Well, when is sine of what angles give a 0? That's on the positive and negative x-axis. So that would mean, make sure that this is not a 0. This is a theta equals. That means theta here is going to equal pi or 2 pi. The direction said between 0 and 2 pi and including 2 pi. Over here, if we try to get theta by itself, we're going to get theta is cosine inverse of 1/2. So when is cosine of an angle equal to 1/2? It's in quadrants 1 and 4. And if that's 1/2, that means this is square root of 3 over 2. That makes this angle pi over 3. So in quadrant 4, you're going to be pi over 3 short of 2 pi. So theta is pi over 3 and 5 pi over 3. So those are our 4 answers for this. Number 3, let's get all the terms on the same side. So we got 1 minus 3 cosine of theta minus sine squared of theta is equal to 0. Well, this can't factor. And that's really what we want to do when we have these equations. We want to try to factor them so we are multiplying things together that equal 0. So I'm going to change this to 1 minus cosine squared. That way this is all in one trig function, and maybe I could factor it then. So this is going to give me 1 minus 3 cosine of theta minus 1 plus cosine squared of theta. Now the 1's cancel, and if I write this with the cosine squared first, I'm going to get cosine squared of theta minus 3 cosine of theta equals 0. Once again, plus 1 minus 1's cancel. Now this has a GCF of cosine. So then, if I set each of these factors equal to 0, solving this first one, we're saying that theta is cosine inverse of 0. When is cosine equal to 0? It's on the positive or negative y-axis. And that happens at pi over 2 and 3 pi over 2. If I solve this other equation, hopefully you can see that this is going to be undefined. When does cosine get as big as 3? Never, because the graph of cosine of theta goes as high as 1 and as low as 1. So this is going to be undefined, which means the only solution to this is is pi over 2 and 3 pi over 2. Number 4, if I add sine to both sides, this will not factor. At first glance, you might think it does. You might say, well, there's a sine in each of these terms, let's factor it out. But they're not. You can't do that because this angle is theta and this one's 2 theta. Let's use the double angle identity for sine, which is going to be sine of 2 sine of theta times cosine of theta. If we do this, we can factor out a sine of theta, leaving us with 6 cosine of theta plus 1 equals 0. Once it's factored, set each factor equal to 0. So we got sine of theta equals 0, and we got 6 cosine of theta plus 1 equals 0. So theta is going to be sine inverse of 0. Sine of theta is equal to 0 on the positive and negative x-axis. So that's going to happen at pi and 2 pi. This over here, if we solve for theta, we're going to end up with cosine of theta is negative 1/6. If that doesn't look familiar to you, it's because it shouldn't. It's not part of the unit circle. This is not a special angle. So if it's not a special angle, how on earth are we supposed to do this? We would do this with a calculator. Now the calculator will not give you the answer. It's going to point you in the right direction. Your calculator is going to give you that pi is 1.738. So how does that affect our answer? Well, just a quick review. Since this is not in radians, since it's not in terms of pi, we need to evaluate what each of these quadrantal angles are as a decimal. Completely around is 6.28. That would be 2 times pi. Halfway around is 3.14. Half of 3.14, I believe, is 1.57. And then, grab my calculator here real quick. Whoops, that's not what I wanted. It's what we call user error here in the business. If I take 3 pi divided by 2, it gives me 4.71. So where does the angle that we have, 1.738, fall? Well, that's going to fall in quadrant 2. Now that actually is an answer. But what does that make the reference angle? That makes this reference angle write this more legibly. That makes this angle here pi minus 1.738, which if you put in your calculator, you're going to get that is 1.404. So our reference angle is 1.404. Since cosine is negative, that's also happening here, 1.404. If you add that to pi, so we got one answer. The other answer is going to be pi plus 1.404, which is about 4.545. So these are the two answers for this. I prefer the ones that don't require a calculator, but sometimes you get angles that aren't special. Next set of problems. Solve the equation below, find exact solutions when possible. So if it's not possible, we're going to have to round from the interval from 0 to 2 pi. So let's see what happens with this. Hopefully you recognize that if we get everything on the same side here and set it equal to 0, there's no factoring that could happen. There's no GCF. Nothing good's going to come of that. But what I recognize, and hopefully you do too, is that 4 times sine of theta cosine of theta is the same as 2 times sine of theta cosine of theta. This is the double angle identity for sine. If you try to get sine of 2 theta by itself, you're going to get sine of 2 theta is square root of 3 over 2. Therefore, 2 theta is sine inverse of square root of 3 over 2. Now, where is square root of 3 over 2? That's in a special right triangle, pi over 6, pi over 3, and pi over 2, 30, 60, 90. Just a quick refresher. If it's positive, it's got to be in quadrants 1 or 2. Which makes this angle 60, which is pi over 3. So 2 theta is pi over 3, and it's also going to be 2 pi over 3. Solving for theta then, that's going to make pi over 6, or pi over 3. Since the original angle that we have here is 2 theta, that means that the period, instead of fitting one period between 0 and 2 pi, we can now fit 2 periods. So that doubles our answer. Each new answer is exactly 1 pi away from one of the first answers we got. That's going to be 7 pi over 6 and 4 pi over 3. Those are our 4 answers for that. Number 6, well, this looks like a bit of a mess here, doesn't it? Well, let's see, what can we do? I recognize that there's a GCF of 2 here on the left. Let's factor that out and see what happens. Hopefully something good. There's something else that I recognize. There's 2 different angles here. There is a 2 theta and a theta. Which of our trig identities can use 2 different angles? Well, that would be the sum angle identities for sine, cosine, and tangent, or the difference ones. Well, this is the pattern for cosine, because we got cosines together and we got sines together. So this is actually going to be 2 times, I don't need the brackets, I'm just going to put them for emphasis. This is going to be the difference identity for cosine. I think you'd recognize it if you look at this for a moment. Remember cosine has these plus and minuses in the opposite spots. So if it's a difference identity, it's plus. If it's a sum, it's a difference. So it's cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. So all that stuff's working out. Check out your notes if you don't recognize that still. Well, what's 2 theta minus theta? Well, that's just theta. So we got 2 times cosine of theta equals -1. Well, that means that cosine of theta is -1/2. So theta is cosine inverse of -1/2. When is cosine negative? It's negative in quadrants 2 and 3. And if this is -1/2, then that makes the y value plus or minus the square root of 3/2, which makes the reference angle pi/3, which makes this angle 2 pi/3, and it makes this angle 4 pi/3. Once again, that's because we know this angle here is pi/3. So therefore, theta is 2 pi/3, or it could be 4 pi/3. Only 2 answers, because once we actually got into solving the equation, the angle was theta, not any other type of angle. Number 7. Well, the directions say, remember, you can check your solutions to 1 through 6 by graphing each side of the equation and find the intersection of the 2 graphs. That's referring to your calculator. Welcome to do that if that's something that you want to do. Number 7, if sine of angle pi plus theta is -3/5, what's the value of cosecant squared of theta? Well, in order to do this, we need to find the value of sine of theta. Then we can reciprocate it and square it. So using the sum identity, we're going to get sine of the first angle times cosine of the second angle plus sine of the second angle times cosine of the first angle. What is sine of pi? Sine of pi is 0. What is cosine of pi? Well, that is -1. This left side simplifies. This becomes 0. This becomes negative sine of theta. Multiply both sides by -1, and we're going to get sine of theta is 3/5. So the question is, what's the value of cosecant squared of theta? Well, if sine of theta is 3/5, cosecant of theta is 5/3. And if you square both sides, you're going to get 25/9. So that is the official answer for this Cool. Number 8, similar question. If cosine of pi over 4 plus theta is negative 6/7, find the value of cosine of theta minus sine of theta. Don't know how this is going to shake out. Don't know how we're going to accomplish knowing each of these things to subtract them, but let's just see what happens if we use the sum identity for cosine. It's going to be cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. Cosine of pi over 4, that is square root of 2 over 2 from the unit circle. Sine of pi over 4 is square root of 2 over 2 from the unit circle. GCF here is square root of 2 over 2, so I can factor that out. Oh, I see. So this is how we're going to get cosine of theta minus sine of theta. We just found it. Now we just need to get that by itself. So I'm going to multiply both sides by the reciprocal of this fraction. That's going to get this cosine of theta minus sine of theta by itself, because those cancel. That's going to give me negative 12 over 7 square roots of 2. You could rationalize your denominator. You're going to find out in AP Calculus. We don't rationalize squat. But I guess we're not there yet. So let's just do this. If I multiply by 1 in the form of square root of 2 over square root of 2, it's going to give me negative 12 square roots of 2 over 7 times 2, which is going to give me negative square roots of 6, negative 6 square roots of 2 over 7. So here's an answer. Here's a more conventionally accepted version of the answer. 9. Gonna sneeze here soon, so I apologize in advance. Turn your mic or turn your speakers down, because when this sneeze happens, I also want to run to the store and get one of those sneeze shields that they have at salad bars. Put that over top of your speaker, because this is going to get nuts. Let's be honest with you. Cosine of pi over 4 minus theta equals 2/3. What's the exact value of this sum? Well, let's just see what happens. Don't have a plan, but I do know this is the difference identity for cosine. If you don't know that, then you need to do yourself some studying. Cosine of pi over 4, same as was on the last side, it's square root of 2 over 2. If I factor that out to the front, the square root of 2 over 2, just like the previous problem. And if I multiply both sides by the reciprocal of square root of 2 over 2, I'm going to get 2/3 times 2 over the square root of 3, which is 4 times 3 square roots of 3. Not 3, I'm sorry, this was a 2. If you want to go super mode and rationalize this, it's going to give us 4 square roots of 2 over 3 times 2. It's going to be 2 square roots of 2 over 3. There's a simplified version of the answer. Simplified meaning a rationalized denominator, and here's a non-rationalized version. Number 10, if cosine of beta is negative 3/5 and tangent of beta is less than 0, what's the exact value of tangent of 3 pi over 4 minus beta? Well, we know from this that beta has to be in quadrants 2 or 3 because sine's negative. We know that tangent of beta is less than 0. That means we have to be in quadrants 2 or 4. You combine these two thoughts together, it's got to be in quadrant 2. So if it's in quadrant 2, I guess that's really not that helpful. At least it doesn't appear to be at this point. If our right triangle has an x value of -3 and an r value of 5, the y value is going to be 4. It's Pythagorean triple. So let's do this difference identity. Tangent of 3 pi over 4 minus beta. That's going to equal tangent of 3 pi over 4 minus tangent of beta divided by 1 plus tangent of 3 pi over 4 times tangent of beta. Tangent of 3 pi over 4, that's a 45, 45, 90. Both x and y are the same value. One's positive, one's negative. It's in quadrant 2, so that makes that -1. Then, oh, I forgot here. You know what tangent of beta is? Using this triangle up here, tangent of beta is going to be -4/3. So I'm going to put that in. So then we got 1 plus -1 times -4/3. This is going to reduce to 3/3 plus 4/3. Tell you what, let me show you a different way to reduce this without getting common denominators. -1 plus 4/3, and then 1 plus 4/3, like so. So one way to pursue this is to say, I don't want any denominators. So in the numerator, there's a denominator of 3. In the denominator, there's a denominator of 3. So I'm going to multiply this by 1 in the form of 3 over 3. And I'm going to write this 3 over 3 for each term. In other words, I'm going to multiply each term in the numerator by 3 and the denominator. So here's what that does for me. It gives me a -3 plus 4. Essentially, I'm distributing this. 3's cancel in that case. Here, it doesn't cancel. 3's cancel in this case, and here, it doesn't cancel. Let me just write it once. So that's going to be over top of 3 plus 4. That's going to be 1/7. Therefore, tangent of 3 pi over 4 minus beta is 1/7. Number 11. If f of theta is sine of theta times cosine of theta, and g of theta is cosine squared of theta, for what exact values of theta from 0 to pi does f of theta equal g of theta? Well, let's see what happens. F of theta equals g of theta. F of theta is sine of theta times cosine of theta. G of theta is cosine squared of theta. If we get all the terms on the same side and try to factor this, which is a major point of emphasis for this chapter, for this section, not this chapter, we GCF of cosine of theta out of this. And then if we set each of these factors equal to 0, equation on the left is pretty simple to solve, I hope. Theta is cosine inverse of 0. When is cosine 0? When is the x value 0? It's on the positive and negative y-axis. But this says from 0 to pi, so I'm just going to use the positive y-axis for this, which is pi over 2. 3 pi over 2 would be another potential answer, but it's not in the domain here. This other equation, if I add cosine to both sides, because that doesn't factor, this question is saying, when are sine and cosine the same value? They're the same value in a 45, 45, 90. And when they have the same sign, S-I-G-N. They're both positive in quadrant 1. They're both negative in quadrant 3. So our answer for this would be the angle formed in quadrants 1 and 3 from the special right triangle, but the domain for this just says quadrants 1 and 2. So we are just looking for theta, which is going to be pi over 4. These are 2 answers for this problem. 12. Sketch a graph of f of theta and g of theta on the axes below. So that was those equations. Let me just write those down so I can see them. Now it's suggesting to use a calculator for this, I believe. Whoops. So let me just give you the cheatingest way possible that I can do this, because, you know, it's what I do. So let's type into y1, first equation, which is sine of x times cosine of x. My second one is supposed to be cosine squared of x. Now this is supposed to be graphed from 0 to pi. And then we're looking for points of intersection. There's a point of intersection. There's a point of intersection, which is saying pi over 2 and pi over 4, which are the answers that we got. So I'm going to throw this graph onto my work here. Yes, I know this is cheating. Nope, I don't care. All right, wonderful. So then the question was, let's see, sketch, which I, kind of did. Then graphically find the intersection, which I just did. How does it verify or contradict your answers? Well, it verifies it. You would write down something like the solutions of f of theta equals g of theta represents the theta values of the points of intersection of the two graphs, which are at pi over 4 and pi over 2. I believe that concludes the homework.